So this is a question related to Chapter 8, Preparation of Solutions. How would 400 milliliters of a 20% solution be prepared using tablets that each contain 10 grams of the drug? So I always take inventory. I know I need to produce 400 milliliters, and that is our solution. Okay, the chemical that has been added is the solute. I also have the strength given to me. It says 20%. We practice this also with Chapter 8, converting your strengths of concentration between percentage, fractions, ratios, as well words. But I can't use the 20% as it is, so I'm going to convert that to its fractions. So the strength is always given, should always be in grams per milliliter. Or if the chemical you're using is a liquid, it would be milliliters per milliliters. But this is actually telling us that the tablets contain, one tablet each contains 10 grams. So we're going to be using the grams per milliliter. So in order to get my percentage back to its fraction, I'm simply going to take that 20 and have that grams with it over 100 milliliters. So if you were to dissolve 20 grams of this drug into 100 milliliters of water, you would get a percentage or concentration of 20%. So just to make sure our math is correct, it's always good just to double back on that. So I'm going to take the 400 milliliters, which is our solution, and I'm going to multiply that against the strength, which is our unit fraction here. And the reason why I'm going to do that is because the question's asking, well, how many tablets you're going to use if each tablet is equal to 10 grams. So I know the question finally is wanting it in tablets, and each tablet is equivalent to 10 grams. So I need to get rid of the milliliters. I don't need that. So I'm going to take our unit fraction and I'm going to multiply it by that 400 milliliters. And with that unit fraction, I know that my milliliters must be on the bottom so that they cancel out. So when I multiply 400 by 20, I get 8,000 grams over 100. And so notice that the milliliters have canceled out, and that's what we want. We're interested to know grams because we are eventually going to use that second unit fraction as one tablet is equivalent to 10 grams. So dividing 8,000 by 100, we get 80 grams. So in basically what we have done up to this point is given a solution of 400 mils, okay, so this is all water in here, okay, or liquid, okay, within that 400 milliliters contains 80 grams of our chemical, which is equal to a 20% strength. That's what we've established so far. But the question's not asking, well, how many grams? If it did, we would be done the question. The question's asking for, well, how many tablets? How would you prepare this solution given that one tablet is equal to 10 grams? So that's going to be the second unit fraction that we are going to handle. So we're going to take the 80 grams and we're going to multiply it by one tablet over 10 grams. And the reason why we have the 10 grams at the bottom is because we're no longer interested in using grams. We're interested in in the tablets. So then we multiply that 80 by 1, we get 80 tablets over 10. 80 divided by 10, it gives you 8 tablets. So with this question, if you were to be given this question on a test, it would basically what you would be saying is in words. This is important if it asks you to not only calculate but to describe the procedure, is you would take 8 tablets of this chemical, dissolve it in 400 milliliters of water in order to get that 20% strength solution.